Hello, algebra students. So we are on chapter 7, section 3, day 2 of this lesson in solving linear systems by linear combination / elimination. So we're going to take this a step further today by doing more than one multiplication in both the system. So our system of equations, 3x plus 2y equals 8, 5x plus 2y equals 12. If you notice, everything is lined up in correct columns, the x's, the y's, and the constants, but we do not have opposites in any of the columns, in either the x or the y terms. So we have to make it so that one of our terms is going to be the opposite of the other. And I'm looking at both my x's and my y's, and it seems that my y's, positive 2y and positive 2y, again, one of them, or either one of them, can easily be changed into the opposite just by multiplying that equation by -1. So I am going to multiply the second equation by -1. So I'm just going to put my parentheses around the entire equation and write -1 outside, because that's going to give me my -2y right here, which is what I want so that I can eliminate those y terms. So my first equation, 3x plus 2y equals 8, and then my new second equation, I'm going to distribute -1 to everything. That's going to be -5x minus 2y equals -12. Notice I multiplied everything in the equation, even the constant on the other side, by -1. Now I have my opposites in the y's, and that's what I want. They eliminate to 0. So let's add the rest of the equation. 3x minus 5x is -2x, and that equals 8 minus 12, which is -4. Now it's easy to solve for x, get the x isolated by dividing both sides by -2, and we have x equals +2. So my x value in my solution, is going to be a +2. So I'm going to write that up there so I don't forget what it is. Now that I know what my x value is, I can easily find out what my y value is. So I can choose either one of the equations. It doesn't matter. I think I'll choose the top equation this time and substitute 2 in for x. So 3 times 2 plus 2y equals 8. So now I can multiply 3 times 2 to get 6, bring down the rest of that equation. Now I need to get my constants on one side, so I'm going to subtract 6 from both sides, and that gives me 2y equals 2, which it's easy to find out what y is by dividing both sides by 2, and that gives me a value of 1 for y. So my solution to this system of equations is 2, 1. In our next system of equations, x plus 2y equals 5, and 5x minus y equals 3. Again, our columns are all lined up, but we don't have any opposites in either our x's or our y's. So we have to choose which variable we want to eliminate and which one would be the easiest to eliminate. In this particular system of equations, it's going to be just as easy to eliminate the x's as it is to eliminate the y's. So I'm going to choose this time to eliminate my x's. Now I've got a 5x on the bottom here, and just a plain x in the top equation. So if I want to get rid of my x values, my x terms here, then I'm going to need to make this top x opposite of this bottom x term. So I'm going to need to multiply just the top equation by -5. So now let me just distribute that -5 to everything in that equation, which gives me -5x minus 10y equals -25. Then I can just bring over my bottom equation as 5x minus y equals 3. This way I can eliminate my x terms to 0, and that's what I want, just to leave the y's by themselves. So now I have -10y minus y, that's -11y. -25 plus 3 is -22. Works out pretty easily to divide both sides by -11 to get y equals 2. So now I know that my y value is 2 in my solution. Write it up there so I don't forget. So now that I know that y is 2, I can once again just choose either one of the equations, substitute 2 in for y, and solve for x. So I think I'll take that top equation, and I'm going to say x plus 2 times 2 equals 5. This 2 is in for y. So now just do the multiplication. X plus 4 equals 5. Get the x by itself by getting the constants on one side. Subtract 4 from both sides, and x equals 1. So let me put my 1 here, and the solution to this system of equations is 1, 2. Sometimes we have systems of equations that not only don't have any opposites in them, but where we're going to have to actually multiply both of the equations to be able to get opposites so that we can eliminate either the x's or the y's in our system so that we can solve. So I've got 2x plus 6y equals 4 and 3x minus 7y equals 6. I'm lucky that my columns are already lined up, my x terms, my y terms, and my constants. But again, unfortunately, we don't have anything that's opposite right off the bat. So we have to fix it so that we can have opposites. So my coefficients in my x terms are 2 and 3, and 1 is not a factor of the other, so we can't use either one of those. My y coefficients are 6 and -7. Neither one of those are factors of each other, so we can't use either one of those. So we're going to have to make a decision. Do we want to get rid of our x's or get rid of our y's? And we're going to have to find the least common multiple, or the least common denominator of both of our coefficients so that we can get the opposites that we need to eliminate. I think working with 2 and 3 are going to be easier than working with 6 and -7. So I decided that I'm going to eliminate my x's in this system of equations. So I'm looking at the coefficients 2 and 3, and I'm thinking in my head that 6 is the smallest number that both 2 and 3 can go into. So I need to make my coefficients in my x terms, one has to be 6 and one has to be -6, so that I can make 0 out of them and eliminate that. So if I want my top equation to be to have the x to have a coefficient of 6, then that means I'm going to have to multiply this entire equation by 3 to get that 6x for my x term. And then I'm looking at my bottom equation, and if I want my x term to be -6x so that I can eliminate, then I'm going to have to multiply that entire equation by -2. So this is one of those examples where both of the equations have to be multiplied by something so that we can get opposite terms in either the x's or the y's. And again, I chose the x's in this particular system. So let's go ahead and make our new equations. The first one, let's just distribute that 3 to everything inside the parentheses. So we have 6x plus 18y equals 12. And in our second equation, we're going to distribute that -2 to everything inside the parentheses. So that's going to be -6x, and that's what we want, plus 14y equals -12. Did I do that right? Yes. All right, so now let's add those two equations together, and the x terms eliminate, which is what we wanted. And 18 plus 14y is 32y equals, looks like 0. So that's easy to do. Divide both sides by 32, and y equals 0. So then I can put my y value as 0 up in my parentheses for my ordered pair for my solution. So now that I know that y is 0, I can easily find out what x is by substituting 0 in for y in either one of the equations. Once again, it does not matter which one you choose. I would probably choose the first equation because it doesn't have any negatives or whatever. So I'm going to put 0 in for y in the first equation. So I have 2x plus 6 times 0 equals 4. So then doing the multiplication, I have 2x plus 0 equals 4. Well, adding anything to 0, as you know, doesn't change what you've got, so that's just 2x equals 4, and that's easy to find out what x is by dividing both sides by 2, and x is equal to 2. So I'm going to put that up here in my parentheses. So the solution to this system of equations is 2, 0. So in our next system, we have 3x plus 2y equals 8, and then in our second equation, we have 2y equals 12 minus 5x. Now, you should be noticing something about that second equation, and hopefully you have figured out that the columns are not lined up. So before we start to solve anything or eliminate anything, we have to line up those columns. So the easiest thing to do, if I look at that second equation, we're going to have to bring that negative 5x over to the left-hand side on the left of the equal sign. So we can do that by adding 5x to both sides and then writing that in the same format as our first equation. So we have 5x plus 2y equals 12. And so that's what we're going to use, which means the exact same thing as 2y equals 12 minus 5x. It's just in a different format. So now our columns are lined up. And I'm going to rewrite that just for my own sake here so I can see what I'm showing you. 3x plus 2y equals 8, and 5x plus 2y equals 12. All right, so now that the columns are all lined up, our x's, our y's, and our constants, we can figure out which variable, the x's or the y's, would be easiest and fastest to eliminate. And since I'm looking at my x's, which 3 and 5 are not factors of each other, but I'm looking at my y's, and I've got a positive 2y and a negative 2y, it'd be very easy to make those into opposites by just multiplying, really, either one of the equations by a negative 1. That will give me a negative 2y. So I think I'm going to take the bottom equation, and I'm going to multiply that by negative 1 all the way across. So my top equation, 3x plus 2y equals 8, and my new bottom equation, negative 5x minus 2y equals negative 12. So now I have my opposites in my y terms, which add up to 0, which is what I want. Those eliminate. And let's add the rest of the equation. 3x minus 5x is negative 2x, and 8 minus 12 is negative 4. So then it's easy to find your x by dividing both sides by negative 2, and we have x equals 2. So I'm going to start my ordered pair up there with 2 in the x place. So now that I know what x is, I can go back to my original equations, and I can substitute 2 in for x in either one of those. And I will probably choose the top equation since it's in the form that I'm used to using. So 3 times 2 plus 2y equals 8. So let's multiply and say 6 plus 2y equals 8. I want my constants on the same side of the equal sign as always. To do that, I need to subtract 6 from both sides, and I have 2y equals 2. And now it's pretty simple to find out that y is equal to 1, 2 over 2. So I'll put the 1 up in my y place in my ordered pair, and the solution to the system that we have is 2, 1.